Imagine you're on a raft in the middle of a calm, dark ocean. Suddenly, you feel a current, gentle at first, but undeniable. It's pulling you, your raft, and everything floating nearby towards a distant, unseen shore. You can't see what's pulling you, you can't hear it, but you can measure your own movement. You are being drawn towards something. Now, scale that up. Your raft is our entire Milky Way galaxy. The ocean is the universe. And that mysterious current is real. For decades, astronomers have known that our galaxy, along with thousands of our neighbors, is being inexorably pulled through space at a staggering 1.4 million miles per hour towards a specific point in the cosmos. We are caught in a cosmic river, flowing towards a gravitational anomaly so massive, its true nature remains shrouded in mystery. We call it the Great Attractor, and it's hidden in plain sight, lurking behind a celestial curtain of our own making. The story of this discovery begins not by looking out, but by looking back at the very dawn of time. In the 1970s, astronomers were meticulously studying the cosmic microwave background, the faint afterglow of the Big Bang. They expected this ancient light to be almost perfectly uniform across the entire sky, a smooth echo of creation. Instead, they found a strange imbalance. One side of the sky was infinitesimally warmer, and the other, infinitesimally cooler. This wasn't a flaw in the universe. It was evidence of our own motion. It meant our entire local group of galaxies was hurtling through the cosmos relative to this ancient light. The expansion of the universe explained our general movement away from everything else, but this was different. This was a specific, directed velocity, a peculiar pull towards a single, unseen destination. So the cosmic hunt began. Astronomers pointed their telescopes in the direction of our motion, towards the constellations of Norma and Triangulum Austral, and began to map everything they could see. They found that not only were we moving, but so were our neighboring galaxy clusters. The Virgo cluster, the Hydra Centaurus supercluster, all of them were streaming in the same direction, like iron filings being drawn to a colossal, invisible magnet. But here's where the universe threw up its greatest obstacle. The direction of this pull pointed directly through the densest, most crowded part of our own galaxy, its dusty, star-filled plain. The heart of the Milky Way, with its billions of stars and vast clouds of obscuring gas, acted like a blindfold, blocking our view of what lay beyond. Astronomers call this region the zone of avoidance, a fittingly ominous name for the shadow that concealed our cosmic pursuer. For years, the Great Attractor was a gravitational ghost. We could feel its immense presence, calculating its mass to be tens of thousands of times greater than our own galaxy, but we couldn't see it. It was like trying to understand a giant standing behind a frosted glass door. You see the distorted shape, you feel the floorboards creak under its weight, but you can't make out the face. To peer behind this curtain, scientists had to abandon visible light. They turned to wavelengths that could pierce through the galactic dust, like infrared and X-rays. Slowly, painstakingly, they began to map the hidden universe. What they found was breathtaking. A massive supercluster of galaxies, now called the Norma Cluster, sitting right where they predicted the Great Attractor should be. It seemed the mystery was solved. But astronomy is rarely so simple. As they refined their calculations, they realized the Norma Cluster, as gigantic as it was, wasn't massive enough. Its gravity could only account for a portion of the pull we were experiencing. The ghost was real, but it was bigger than we had imagined. The search pushed further, deeper into the zone of avoidance. And there, looming behind the Norma Cluster, they found the true culprit. A structure so vast it almost defies description. The Shapley supercluster. This is the largest known concentration of galaxies in our local universe. A cosmic continent containing over 8,000 galaxies with a mass of more than 10 million billion suns. The Great Attractor, it turns out, wasn't the final destination. It was merely a massive gravitational way station, a significant foothill in front of an immense cosmic mountain. We, our Milky Way, the Andromeda Galaxy, and our entire local group are not just being pulled by one cluster, but are part of a vast river of galaxies flowing across hundreds of millions of light-years towards this even greater gravitational basin. The shadow wasn't cast by some external object, but by ourselves, and it was hiding the sheer scale of the cosmic neighborhood we truly live in. We now know what is pulling us, but as we hurtle through the void at over 1,000,000 miles an hour, the real question becomes, what lies beyond the horizon we are so desperately racing towards?